Yeah, I'm not speaking to just you personally, Ramsey. I'm speaking to the whole class.
So
go correct your homework if you haven't it done. Now we're going to move on to today's lesson. First, we want to look at that question from the homework, the last question in blue, which was 2 classes contain 8 boys. So 2 classes each contain 8 boys. So let's call one class A and another class B. I think that's where it is. In one class, the ratio of boys to girls is 1 to 2. So in, let's say, this class, the ratio of boys to girls is 1 to 2, B to G. And in this class and the other class, it's 2 to 1. So 2 to 1, boys to girls. So remember, this is the blue level, so a problem-solving question with words. If the 2 classes combine, what will be the new ratio of boys to girls? Okay. Well, in this class, there's 8 boys. That's one part. Double that part will be 16. So 1 to 2 would be the same as 8 to 16. If you want, you can unsimplify by multiplying both sides by 8. So 8 to 16 would be that class. This class is slightly different. 8 boys, but the girls, there'll be half the amount of girls this time, 4 girls. 2 to 1, just twice as many boys. This is homework, so it needs to be done at home, perhaps over the weekend. You would have done it. That is when you do homework. Okay, always check your manage back for homework. We set it on Wednesday. It was due for today, Monday. Okay, so now I combine these 2 classes. So let's just look at the boys. There's 8 boys and 8 boys. That's not too bad. That's 16 boys. Girls, well, there's 16 girls in this class and 4 girls in that class. So that's 20 girls. Now, they ask, anytime you simplify, you've a ratio like this, you can simplify it. So I'm going to simplify it. Divide both sides by 4 is the way to simplify this one, or I could divide by 2 twice if I want. 16 divided by 4 is 4. 20 divided by 4 is 5. So the ratio is 4 to 5. And that's one of the trickier questions for blue. Now, on Thursday in the race to 8, we had the final question. It was a little tricky question. It was, which was better value? 750 grams and its price was $2.20, or 1 kilogram of 1 kg and its price was $2.80. Okay. And which is better value? Well, I know that this one costs less money, but the 750, but am I getting better value by buying more and maybe it would be cheaper? We're not entirely sure because we're not comparing like with like. So this is a cost comparison if you want, or you can use something called unit rates to compare. And that's if we get them both to the same unit. So at the moment, these are different units and these are different prices. So we want something to be the same so we can compare. So what a lot of people did was they said, well, if I buy 4 of these 750 grams, I get 3,000 grams if I bought 4 of those. And if I buy 3 of these 1 kilograms, I also get 3,000 grams because there's 1,000 grams in a kilogram. So that is something to compare. I have a unit here I can compare. If they're both at 3,000 grams or 3 kilograms, I can compare the 2 prices. So I need to multiply this price by 4 because I'm buying 4 packets of that, and this price by 3 because I'm buying 3 packets of that, so I can compare. This price by 4 is 880. So the 750 grams, well, I'm getting 4 packets of it, sorry, 3,000, is 880 because I multiplied this price by 4. This one The 1,000 grams, when I look at the 3,000 grams price, or 1 kilogram and 3 kilograms, if I multiply this by 3, I get 840. That's the price of 3. Now it's far easier to compare which one is cheaper. For 3,000 grams or 3 kilograms, this one is better value. So it would also be better value at the 1 kilogram price. So the best value, or best buy it's called sometimes, is the 1 kilogram at 280. So this is called unit rates, if I was comparing something like that, or more commonly called best buy. So how do we compare the price of two different things if they're different weights? Is usually with best buy. And usually you see, if you go to the supermarket, if you buy a larger quantity, it'll be a better buy price-wise per unit rate than a smaller quantity. So if you buy in bulk, it's better value. But this is how you would work out and compare. Another way you could compare this is you could do the price per 250 grams. So 250 grams of this, so remember that my price is 750 grams is 220. So what's 250 grams of this? Let's divide that. If I divide that by 3, I get 250. So I need to divide this by 3 to get the equivalent price. Now I can do that. If I want, I can have my calculator involved in this one, which I will. 220 divided by 3. It's going to be a decimal, but it's about 0.73 recurring, so a little dot for recurring. Okay, and so that's 250 grams. Cost that much. If I compare the 1 kilogram, which is 1,000 grams, to 0.80, to get that to 250 grams, I can divide by 4. And dividing this by 4 gives 70 cents. So, which is cheaper? Once again, the 1 kilogram is working out cheaper at the same rate, or the same unit rate I can compare. And this is just another method of doing the same question. Here's my comparisons. They're both at 250 grams. So I can compare the price there and get a best buy. This one is cheaper, therefore it's better value. The same answer as I got before, because it's the same question. Oh, Asher. Well, I was wrong. I was in a rush. Maybe we have to take that place off you. That is the method. But that wouldn't be your answer. What wouldn't be my answer? The final answer? Well, that's the final answer. The best buy would be 1 kilogram at $2.80 because it is cheaper. Whichever method you use. Okay. Yeah, that's not my final answer. My final answer would have to be a statement of which is better value. Okay. So that was just a recap of some of the blue level questions. Now we will be looking a bit more at best buys, so using rates. And I want to just use one example of a rate in everyday life. So rates in everyday life, perhaps the most obvious, or almost obvious example is maybe kilometers per hour, or meters per second. So I'm using shorthand M for meters, km for kilometers. So you could also get maybe price per meter. So maybe you're buying some material and you get the price per meter, or a price per weight. Maybe it's dollars per kilogram, which we kind of looked at in the last example. It's all this per. It's this word is used a lot in rates. If you look at the second unit, so there are two different units. That's unit 1, that's unit 2. They're not the same unit. Remember, ratios had to be compared. We were comparing the same unit. It was people or weight or price. It was always the same unit. We couldn't compare if they were in different units, such as when we had dollars and, if we had kilograms and grams, we had to convert one of them to the other before we could compare. In this case, rates are two completely different units. So if I say 60 kilometers per hour, which could be written like that, they are two different units. Kilometers is one, and time and hours is the other. Now, the thing about rates is one of them has to be down to 1 unit. So that's 60 kilometers per 1 hour. Is one way you could write that. 60 kilometers per 1 hour. This is the key to rates. 1 unit is a value 1. Okay, it has to be down to 1.
Will we be taking notes on this?
You don't need to take notes on this. No, there's another video that you can take notes on, which is on Manage Back already. You can take notes if you want.
Mr. Collins?
Yes.
My phone died, and the Wi-Fi that I was getting, it was coming from my phone, so I had to leave the call.
Okay, that's fine.
Took me out of the call. I didn't have no.
That's fine. Okay. So that means a statement like this. If I travel 120 kilometers in 4 hours, that is not a rate at the moment, the way it's written, because neither of these are in one per unit, 1 unit. But I know if I divide by 4, if I divide one into the other, I would get hours down to 1. How many kilometers did I travel in 1 hour? Well, divided by 4, we'll get 1 hour. And that's 30 kilometers in 1 hour. How do I write that as a rate? 30 kilometers per hour, you would say, or like that. So the rate always gets back to 1 unit. Now there's more examples of that on the YouTube video, which you can check out. The basic rates YouTube video, which has a few, including clicks per second if anyone does the CPS thing on their computer. That's a rate. Now, I want to just do one final example using a guy called Usain Bolt. Who's Usain Bolt?
He's a runner.
I think he was that one guy who ran 100 meters in 9 seconds.
He's that one guy who ran the 100 meters, yeah.
He was in the Olympics from Jamaica.
Yeah,
He was, yeah. He's the world record holder.
He's the world's fastest man.
He is.
Yeah, he's the world's fastest
World's
man.
fastest sprinter.
Does anyone know what time he ran the 100 meters in?
9.18 seconds, I think.
No, not quite that fast. It's 9 point something.
9.8 something.
9.58 seconds. He ran 100 meters. Now, my quest in the next 3 minutes is I'm going to see how fast that is in kilometers per hour. So I know he does. So kilometers per hour is a rate. I want to see what his rate is in kilometers per hour. I don't want it anymore in 100 meters and seconds. I want to use kilometers per hour so I can compare it to my motorbike. All right. Thoughts on this? Well, if I need kilometers, I need to, at the moment I have in meters, I have 100 meters. And seconds, I need that in hours. So this needs to go to kilometers, and this needs to go to hours. Okay.
Excuse me?
Yes.
Why can't it be in seconds and meters? Does it always have to be in kilometers and hours?
No, it doesn't always. It could be in meters per second, but that's too easy because I want it in kilometers per hour. Meters per second? Meters per second? How would I get
Couldn't you convert the seconds into hours? Like, I know that would be really small, like 0.958 seconds.
Ethan, if anyone feels like doing this quicker than me and see if your answer matches mine, go for it and type your answer into the chat and see can you get an answer in kilometers per hour. I'm going to do this nice and slowly, and if you want, you can put it in your notes. But if you want to try and beat me, go for it. First of all, I'm going to get meters per second. If I want to, so this is 100 meters in 9.58 seconds. If I want to get this down to 1 second, what am I dividing by?
9.58.
Exactly, 9.58. If I want to get it 9.58 times smaller, I divide by 9.58. Now, if I do it to that side of the rate, I must do it to this side. So I divide by 9.58. Now, this will definitely require calculator use. Okay, so I'm going to turn on my calculator. I'm going to do 100 meters divided by 9.58. Okay, and that gives me 10.438. We'll go to 3 decimal places. 10.438 meters in a second. So that's his rate. That is one rate. So I could write that 10.438 meters per second. So notice that little slash there. That's quite fast. That's 10 meters is quite a long distance. Walk out 10 large steps on your in your garden maybe, and you will see that's quite fast. Okay. Have we got any answers in the chat for?
Mr. Collins, do you have
Yeah.
a video we can watch on?
Sorry.
Do you have like a video we can watch, or are we meant to be taking notes on this?
There is a simpler video, so just watch this one. I'll put this up as well, but there's a simpler video that you take notes on later. Okay, so just watch this and try and follow along. You don't have to take notes on this one. Right, so that's 10.48 meters in a second. So I want to convert that rate.
Excuse me.
Yes?
Sorry, you said that we could try and get the answer ourselves. I was trying to get the answer. How
Yeah.
did you get 10.438 meters per second?
I divided by 9.58.
Okay, so you divide 100 meters divided by 9.58 to get the
10.438 meters in 1 second. Watch the video again when I put it up on YouTube to do, because I've gone through this with everybody else. Okay. This is a double lesson, guys. Yeah. Okay. So 10.48 meters per second. Right. Now, going at that rate, 10.438 meters per second. I'm just writing it over here. I'm going to do a sidebar over here. Okay. How many meters would he go at that rate in a minute?
Times it by 60.
Boom, times it by 60. 60 times as far. So I'll get my previous answer and I'll times it by 60 because it's 60 times 60 seconds in a minute. That's 626.30. Well, let's round that 4 to a 5. Rounds up. That's an 8. Okay, so that's meters per minute. Where am I going with this? I want my final answer to be in hours, kilometer per hour. So I have now meters per minute. I'm going to get meters per hour. What would I need to do again?
Times it by 60.
Times it by 60 again. So once I times it by 60 again, I get this large number. 37,578. Okay. 37,578.288. Okay, and I've rounded it again to just 3 decimal places. Okay. Well, that's not what I want, but I do have one of the units. I have per hour, but I need this to be in kilometers, not meters. So I'll jump straight to kilometers per hour. How do I get from meters to kilometers?
Times it by 1,000.
1,000.
Times it by 1,000?
Divide.
Divide.
Well, which would make the most sense? If I times this answer by 1,000, I'm going to get 37,578 kilometers per hour. I don't think he's that fast. I think an answer by dividing by 1,000, 37.578 rounded kilometers per hour. So about 37.5 kilometers per hour was Usain Bolt's speed as the fastest man in the world. So perhaps that's a bit slower than you thought. Perhaps it's faster than you thought. So if you're in the car or on a motorbike at some stage in the next few days, maybe ask the driver to go at 37.578 kilometers per hour and you can see how fast Now that is an average speed. That is not as fast as speed, is it? Someone tell me why it's not as fast as speed.
It's rounded.
No, not because it's rounded.
Because it's not actually in seconds, it's in hours.
No, that's not the reason. Think about it. Okay, this is not really a maths question. It's more of a logic question. If you start a race, what speed do you start at?
A slower speed, like 0.
You start at 0. He used to accelerate. So if his speed is here on this graph and time is this way, he accelerates and then reaches the top speed. And I think he actually, if he decelerates, he can only hold the top speed for a very short period of time. The average speed, which we worked out here, might be somewhere around here. So he drops above and below it. That's an average speed. The average time. Anything that's an average, there can be values above and below it. But he has to start at for 0 speed. He has to go from 0, so he has to accelerate really fast and then reach a top speed. So his top speed is probably over 40 kilometers per hour. And you can look that up if you want to research. What's Usain Bolt's top speed? It's going to be over 37.5. But his average speed in kilometers per hour is 37.5. And we worked that out. Okay. So that's an example of a very difficult rates question. So remember, a rate. The key to a rate is one of the units is at 1, if that makes sense. There's going to be 2 units in a rate, and one of them has to be right back down to 1. Sorry?
Mr. Collins,
Yes.
I found out Usain Bolt's top speed.
Oh, so we have some. Oh, and so did Asher. Is it the same as Asher's answer? 47.72?
No, it was 44.72.
Oh, 44. Okay, I read it wrong. Yeah, so going back to, side note, going back to Usain Bolt. He starts at 0. He speeds up to 44.72. And he probably slows down a bit by the time. So this is a distance of 100 meters. If you want to do distance, not 10 meters, 100 meters. That's distance against speed. Okay, so you can see at different stages, and at some stage, the same graph, he will average out at 37.5 kilometers per hour. So distance over speed. Okay, that's kind of cool that he reaches that speed. So once again, you can maybe compare those speeds, ask your driver to hit 44.72 kilometers per hour and see how fast that feels. And that's a speed that Usain Bolt, the fastest man in the world, was running at. That's kind of cool. I do encourage you to watch that race, and you can notice him speed up, hit a top speed, and try and hold on to that top speed for as long as he can. So it's, I think it's from the maybe 2010 or 2008. You can check it out. Okay, so the key to a race is that one of the units is at 1. So something per hour, something per minute, something per kilogram, something per meter, something per dollar, and it's always back to 1. And that's how we deal with rates. So what's left for today? So that was me talking for a long time. If you haven't